Hi everyone, this is Top 3D Shop, and in this video we'll tell you about the shining 3D Einscan HX 3D scanner. Having been in the industry for almost 18 years, Shining 3D has established itself as a manufacturer of high-quality 3D scanning equipment. In addition, the company develops and maintains user-friendly and functional software tailored for its scanners. The products are designed by the company's headquarters in China, along with its branches in the United States and Germany. Although not the most expensive model, the Einscan HX definitely belongs to the professional segment of 3D scanners. Now, you are welcome to learn about the scanner itself, its features, and specifics of use, as well as look at some actual scans we made. Let's start with the package. The first thing to strike the eye is the large case in which the scanner is shipped. It is made of high-quality plastic and has 2 reliable latches. Overall, it resembles cases for any professional equipment, whether it be a camera or drone. On opening the case, we see a small piece of paper with the activation key for the Solid Edge Shining 3D Edition scanning application. Then follows a package with 2 connected panels. These are calibration boards. There's also a special pad to help you place the boards correctly when calibrating. The case itself has cavities with everything you need to operate the scanner. Naturally, there is a 12-volt 3-amp power supply with a removable plug and plugs for various types of outlets. Next is a USB flash drive with all the instructions and software, and a set of markers for scanning. As practice shows, with careful use, such markers can be utilized several times, so this number of markers is enough for a long time. The next thing that attracts attention is a long cord. It combines 2 cables for data transmission and power. And now we finally get to the scanner itself. Its form factor resembles similar models of handheld scanners and boasts convenience of use. It has a soft handle in the middle, with all the sensors, cameras, and projectors located on the top and bottom sides. The scanner weighs only 703 grams, which makes it easy to use even for long periods of time. Its handle is equipped with a button used to start and stop the scanning. On top of the scanner, there are 4 more buttons: brightness up and down, zoom in and out. These buttons are surrounded by RGB LED lighting, which helps control the distance from the scanner to the object during the process. On the bottom side are the ports for connecting the scanner, which we'll dwell upon later. Let's look at the technical specifications and features of the Einscan HX. To begin with, this scanner is of a hybrid type. That is, it combines 2 3D scanning technologies. The first, and perhaps the most common one, is the scanning by structured light. We told you about this technology in the Einscan SP scanner review. It uses special patterns projected onto the scanned object, and the cameras record the distortion of these patterns at different angles. Thus, it is possible to determine the distance of specific points from the scanner. In the Einscan SP, the patterns are generated by a standard projector as lines of different widths. The HX has those patterns projected by LEDs in the form of myriad blue dots, but the principle is the same. In this mode of scanning by structured light, the so-called rapid scan, the claimed accuracy of scans reaches 50 microns. The volumetric accuracy, that is, the tolerance for each meter of the scanned object, ranges from 50 microns to 100 microns. Since the scanner is handheld, another important parameter is the scanning speed. In this mode, it stands at 1,200,000 points per second. The camera's depth of field, that is, the working distance from the scanner to the object, is 200 to 700 millimeters, with the average, most optimal distance being about 450 to 470 millimeters. Another important feature of the rapid scan mode is its ability to create full-color scans with textures. The second mode is called laser scan. At first glance, it looks like the mode we've just discussed, aside from a laser grid used instead of LED light, but the operating principle is also different. The laser module displays on the object several laser crosses, and a special sensor detects the reflection of each point and measures the time for the laser light to return to the sensor. Thus, by measuring the delay between sending the beam and hitting the sensor, the scanner can determine the distance of a given point from the scanner. In laser mode, the Einscan HX can capture up to 480,000 points per second. While this is significantly slower than rapid scan, the accuracy of scanning is increased up to 40 microns, with the volumetric accuracy standing at 40 to 60 microns. The optimal working distance to the object during scanning remains the same, 470 millimeters. Both rapid and laser modes use completely eye-safe light sources, so no safety goggles are needed, and it's also possible to scan people. The light hitting the eye is not harmful, even though unpleasant. Let's move on to the connection and initial setup. Everything is very simple. Connect the long cable from the package to the scanner. There are two ports, USB 3.0, Type B, and a power connector, which requires a special plug. It connects only in one position and has a spring-loaded locking ring that holds the plug in the socket. This makes it safe to move with the scanner around the object, not worrying about the power cord being accidentally disconnected. On the other side of the cord, close to the USB plug, is the power supply connection port, and the USB plug itself requires a corresponding port in your computer, USB 3.0 only. It is worth noting that the scanner has fairly high system requirements. At least the Core i7 processor of 8th generation and the NVIDIA GTX 1080 graphics card with 4 GB of video memory. And most importantly, you'll need a lot of RAM. The more the better, but no less than 32 GB. With this configuration, you can use the scanner, but for a comfortable work in all possible modes, it is desirable to have a much more powerful computer. So, the scanner is plugged in, the drivers should be detected automatically. Now we need to install special software, which will process data obtained during scanning. Shining 3D offers the proprietary Einscan software, and the addition for this scanner is respectively called Einscan HX. The latest version can always be downloaded from the Shining 3D website. Once turned on for the first time, the scanner will prompt you to activate the Einscan license. To do this, simply click on the Online Activation button. If the scanner is detected correctly and your computer has access to the internet, you will see a message that the license file has been successfully downloaded. Otherwise, you need to contact the manufacturer to get this file and perform the activation. After that, it is necessary to perform calibration. To do this, take the boards from the kit and place them vertically on the pad so they stand on the outline pictured. Take the scanner and turn it as shown in the application. Press the button on the handle and move the scanner to the boards from near to far without turning it. On the right side of the view screen, you will see 5 bars indicating the distance from the scanner to the boards. You need to make sure all these bars turn green. Perform the same procedure 4 more times, turning the scanner clockwise by 45 degrees. The program will calculate the data and show the average deviation. In our case, it was about 0.03 of a pixel. The next step is the laser calibration. Put the boards on the table with the white side upward, and holding the scanner horizontally over the panels, move the laser from near to far in the same way as we did during the first calibration steps. Now we have 20 bars to make green as well. And the last thing to calibrate is the white balance. The process is similar to the laser calibration, the boards lying with the white side up. There are no bars to fill, just move the scanner from near to far until the calibration is automatically completed. As you can see, the whole device calibration takes only a few minutes. Besides, you don't need to do it every time before using the scanner. It's needed only if your scans have obvious distortions in size or shape. For the first test, we decided to scan an art model. Scanners like the HX are often used for museums to digitize objects of art and history, such as paintings, sculptures, and so forth. We took a picture made of leather. It has a complex relief and a lot of different colors. Since we needed a whole model with all of the textures, we opted for the rapid scan mode, as there's no way to get textures with lasers. Besides, we needed to scan the backside of the picture as well to obtain an entire model. But the backside has neither distinctive geometry nor any explicit textures. Therefore, we picked up some markers. We stuck them on the back and one of the sides of the object for the future scans to be successfully aligned. By the way, markers should be stuck in a chaotic manner, without any order. Otherwise, the scanner can get confused. So, in the Einscan interface, we chose the fast scan mode and created a new project, entering the settings menu. In the first column, it is requested to choose between texture and non-texture scanning. Our test required scanning with textures. In the second column, one needs to select the type of alignment. There are 4 of them. The first is alignment by markers. This mode would not work for us since there were no markers on the front side of our picture. The second mode is alignment by features. This didn't suit us either. The backside had markers on it, and the alignment by geometry would not work there. The third mode is hybrid. That is, both markers and geometry features are used for alignment. That's exactly what we needed. When scanning with textures, it is also possible to align scans by features of those textures, and this mode could work for us if we wanted to scan the front side only. So we went with hybrid alignment. And the last item of settings is resolution. It can be adjusted from 0.25 of a millimeter to 3 millimeters. These are the settings for the density of a point cloud obtained during scanning. For objects characterized by simple geometry, with smooth planes, sharp angles, and without small elements, the resolution can be set quite low, and this will be enough to get all the relevant information. More complex and detailed objects require higher resolution. Keep in mind that the resolution has a direct impact on the amount of data that will need to be processed. If your computer is not quite powerful and has little RAM, you won't be able to scan with high resolution. Everything will be constantly freezing up, and you'll be getting messages that there's too much data and not enough memory. So it is crucial to choose the resolution not only with the object's features in mind, but also according to the capabilities of your PC. Our computer is powerful enough to afford a high resolution. Indeed, the picture is complex, and we wanted to capture as much detail as possible. There are a few more settings in the scan menu. The first is brightness. To scan light-colored objects, the brightness should be low. For dark objects, it is needed almost at maximum. On the other hand, it's not necessary to set the brightness before starting. You can adjust it according to the situation in the process. The other three switches are usually left untouched. The first improves the alignment when scanning objects with no distinctive geometry. The second triggers texture flashing for better uniformity, if needed. And the last one improves marker recognition when scanning dark objects, but it may also decrease the quality of scans. We scanned in 2 steps, first the front, then the back, combining the 2 scans afterward. Here's how it's done. Put the object on the table and press the Start button. The first thing you'll see is a preview. It will show how clearly the scanner sees the object. If necessary, you can adjust the brightness by using the buttons at the top of the scanner. If everything's all right, press the Start button again and start scanning. EXScan will display how the data is collected and immediately aligned. Move the scanner over the object to gradually collect all the data. Since the picture has both light and dark areas, we had to repeatedly change the brightness to capture as much data as possible. The most difficult part was the transition from the front side to the frame. The geometry features there are hardly pronounced, and sometimes our scanner got lost, with music starting to play to signal a problem. In such cases, you need to point the scanner at some area that has already been scanned. The program will match the position and allow you to resume scanning. In addition, you need to keep track of the distance from the scanner to the object. For this purpose, EXScan has an array of bars on the left that show the distance in different colors. In the center, the bars are green, which means the optimal distance. If the scanner is too close, you will see red bars, and if it's too far, then blue ones are on. The same color indication is displayed on the scanner itself, so you don't have to constantly look at the computer screen. Gradually, we gathered all the possible information. The most important thing was to get the scanner to register the presence of markers on the frame. They would be common for the scans from both front and back sides, and would be needed to match them. There should be at least 3 such common markers, and preferably even more. The process of carefully scanning the front side took about 10 minutes. When all the necessary information has been obtained, press the Start button again to pause the process. As you can see, along with the object was captured the table on which it was laying. Such data must be removed. Hold down the Shift key and highlight some areas to delete. Click on the cutting plane icon to create a plane that will cover all selected areas. If necessary, raise the plane so that all the redundant data is read. Click on Apply, and that data will disappear from your scan. In case any excess areas remain, they can also be selected by holding Shift and removed by pressing Delete on the keyboard. Or you can click Delete Selected Data in the program. When all that cleaning is complete, click on the Stop button in the program, and the final point cloud will be created based on the received data. At first glance, it turned out very well. Still, the backside was yet to be scanned. For this, we opened the tab Project Group and added a new project. The settings were left the same. So we turned the picture and scanned the other side. Thanks to the markers, the alignment here was even easier and faster since it was much more comfortable for the software to match the scans based on the position of the markers. Again, the most important thing was to fix the common markers on the frame. In the process of scanning, it is possible to pause the process, examine the object in the program, and if some data is missing, press Start again and scan the desired areas. The last thing to do is to match the two scans received. For this, click on the Align button. In the upper left window, choose the project from which the scan will be fixed. The bottom window is for the project to be aligned. There are 3 modes of alignment. The first is by geometry features, which would scarcely work in our case as there were few pronounced features in the alignment areas. The second mode is manual. Hold Shift and select at least 3 common points in both scans, and EXScan will try to rotate the second scan so that these points are matched. The third mode is alignment by markers. Here, everything is straightforward. The trick is to have at least 3 common markers on both scans. We had enough of them, so the third mode it was. As expected, EXScan aligned the 2 scans correctly without any problems. Thus, we got quite dense point clouds with all the necessary data, matched the 2 sides of the picture, and moved on to the final step, the creation of a polygonal model, the so-called mesh. For this, click on the Mesh Model button. Here are 2 main options: to make a watertight one-piece model, then the program will automatically close all the holes, or leave the model as it is, without additional processing. Also, there are a few more parameters, such as the quality of the final model, filtering, removing small floating parts, limiting the number of triangles, removing spikes, and automatic filling of marker holes. In the case of art objects, it is natural to make a watertight model. Depending on the computer performance and complexity of the model, the process of creating a mesh can take from 1 to 10 minutes. The post-processing menu also has several tools for modifying resulting meshes: simplification, smoothing, the removal of small elements, and the like. If we had chosen a non-watertight model, it would have been possible to manually fill the holes or do it automatically with one of the 3 suggested algorithms. If everything's alright, you can export the model to one of the popular 3D formats. When scanning with textures, the most optimal format is OBJ. The only problem is the textures themselves still contain markers. And even after all the holes are filled, these spots have textures with markers painted on them. Even so, this problem has a simple solution. Since textures are essentially regular JPG or PNG files, you can safely process them in Photoshop. You can either delete the markers with automatic redrawing of the deleted areas, or replace those spots with similar areas without markers. Keep in mind that you shouldn't change the size and proportions of the images, otherwise they won't be smoothly superimposed on the model. After all these manipulations, we got a whole full-color 3D model of the picture from all sides. The result was really impressive. For the second test, we tried scanning a small steel technical part. Actually, Shining 3D recommends using the Einscan HX to scan objects from 30 centimeters to 3 meters, but it was interesting to try a smaller object. Besides, the part is steel and shiny. Scanning in rapid mode without using a special matting spray is nearly impossible. With laser scanning, however, this should be no problem. There are much fewer settings for laser mode, since alignment can be performed only by markers, and there is no texture option when scanning with laser. Therefore, you only need to select the resolution. For this mode, it can be adjusted from 3mm to 0.05 of a millimeter. Select the resolution in the same way as in the first test. We chose 0.2mm. As we said before, laser scanning allows solely for markers. However, it was inconvenient to stick them to this object because of its curves. Such holes would be difficult to fill. When scanning small objects, you can stick markers not to the object itself, but to the surface on which it stands. And it's even better to print several small truncated pyramids on a 3D printer and stick markers to all their sides. We randomly scattered such pyramids around the object and placed the part itself on a small elevation. The scan settings offer to choose between 3 types of an object: normal, reflective, or black. The following 2 parameters, brightness and data, change automatically once you select the type. If we chose the normal mode for this part, the surfaces would be captured, but very slowly and incompletely. We opted for reflective to obtain a much faster and more quality result. In laser scan, the information is captured only in places where the lasers pass over. Therefore, the data is collected by smoothly moving the beams over all surfaces, slightly turning the scanner. Moving around the object, we collected all possible data in this position. Then we did a couple more scans, laying the part on its side. Alignment by markers would not work here since we changed the position of the part relative to the pyramids around it. But EXScan was able to align the projects by geometry features. We ended up with a whole piece. Sure, it was possible to create a watertight mesh, and it would look good. On the other hand, though, technical parts are usually scanned for one of the two specific purposes. The first is reverse engineering, which means the creation of a 3D model that is a copy of an existing object. For this, the scanner comes with a license for professional software from Siemens, adapted for Shining 3D, Solid Edge Shining 3D Edition. It allows creating a complete parametric 3D model using the scan as a reference. The second usage is the inspection of real objects. That is, a resulting scan is compared with the 3D model from which the object was created, in order to check the manufacturing quality and dimensional accuracy. In both cases, it is essential to use original scans without additional processing, since filling the holes or smoothing inevitably entails some minor distortions of the geometry. We also decided to check how accurately the Einscan HX determines the size of objects. For this purpose, we used measurement tools in EXScan, specifying 2 points for the program to show the distance between them. We measured the same distance with a caliper on a real part to compare the values. The difference was about 0.05 of a millimeter, which is in line with the claimed specifications. For the third test, we tried to scan a much larger object, a part of the bumper from a Skoda car, the area where a headlight is installed. In this particular case, it is difficult to imagine what it could be used for, but if it were a bumper from some vintage car for which spare parts are hard to find, scanning the headlight seats would allow making the necessary parts without multiple adjustments and measurements. The plastic bumper is of gray color and has a lot of indentations, holes, curves, and other irregular elements. We covered it with markers and started to scan in laser mode. Everything went fine. The device easily captured the gray plastic. Except we had to twist the scanner at every possible angle to capture the recessed areas. Aside from a couple of places the laser couldn't physically reach, we were able to shoot all the areas. The bumper was scanned from both sides, with the two projects subsequently aligned by geometry and markers, and it worked fine. Some of the holes were filled manually just to make the output look better. As a result, we got this model. There is more than enough information here to either reverse engineer this object or create a new headlight to fit this bumper. And the last object we chose to scan is also a car part. This is an H-arm from a BMW. It is made of aluminum and has a rather complex shape, holes, small elements, and shiny areas. Similar to the bumper, we also covered it with markers, trying to place them only on the flat areas. We scanned in laser mode, using the settings for reflective objects. The scans taken from different sides were easily aligned by markers. The only difficulties were caused by silent blocks. The settings for black objects came in handy, but it proved impossible to capture the information in the recesses. However, the data obtained was definitely enough for further manipulation, whether it is inspection or reverse engineering. For the sake of interest, we tried to make a watertight model with automatic hole filling, and it turned out great. In this form, the model can be used for demonstration purposes or, for example, in a video game. Now, let's draw a conclusion. As expected, the Einscan HX coped with all the tasks without any problems. Its capabilities are quite in line with the declared specs. The model seems to have only 2 shortcomings. The first is the difficulties in scanning small objects. Still, we did manage to scan a part much smaller than the minimum declared size, but it would be hard to scan some jewelry, for instance. And the second drawback is perhaps the lack of auto-scanning mode using the turntable. The whole process is carried out by hand. The advantages of the scanner are much more numerous. The most important of them is its versatility. The device offers enough scanning modes to solve almost any task. The EXScan software is convenient, simple, and intuitive. It works fine and stable, but it does require a very powerful computer. The laser mode allows for easy scanning of black and shiny objects without the need to matte them. Of course, it has some limitations too. For example, you will need matting spray when scanning a completely mirror or transparent surface. A built-in color camera enables you to scan textures without any additional equipment. And there's a lot more. In other words, the Einscan HX really impressed us. This is Top 3D Shop with the shining 3D Einscan HX 3D scanner review. Subscribe to our channel, leave comments, and hit the like button if you've enjoyed the video. See you soon!